welcome to this lesson. In this lesson, we're going to talk about sine function, its graph and domain and range. Before that, we like to review the definition of function, right? At the beginning of the semester, we talk about the definition of function. And here we have been talking about functions, right? We talk about the functions we used to know and trig functions, yes, they are functions. And each one of them is a rule that assigns to each input in the domain exactly one output in the range. So in this section, we're going to study sine as a function by itself. Okay, so we're going to study the domain. Okay, we know that domain are inputs, right? The collections of all possible inputs. But what can they be? What values can they be, right? And we understand these are angles. These are angles. They are also, there's another word I'm gonna introduce, and actually we have introduced that earlier. They're also arc lengths. They're also arc lengths. And the output are ratios. The output are ratios. But we do all of these when we talk about function, right? We talk about sine function. We talk about function under this stage set, which is A, R, D, okay? Angle, a measurement, reference angle, and definition. And in this case, of course, we only talk about sine function. So we're gonna remove all of these other ratios, okay? So our task is to draw pictures, because we know that every rule has, it's a graph. Every rule corresponds to a graph, right? So we want to figure out how the graph is going to look like. I understand many of you that you know the curve of sine, right? If I ask you to draw it, you can just give me the curve. But do we really know the meaning? Do we? Right, so this is what we're gonna focus on. And once again, as we're gonna focus on the meaning of this function, right? The meaning of the curve. And of course, at the same time, we want to discover domain and range, okay? So we're gonna discover domain and range. So once again, what is domain and what is range? On a graph, domain is the horizontal span. For example, okay, in this picture, right? We're going to draw the sine curve from this picture, What is the domain, right? The domain would be the horizontal span, how far it expands in both directions, right? In both directions. Are there points in between we have to avoid? And what are the range, right? The range are the vertical span. How high it can go, how low it can go. So domain and range will be studied at the same time. So let's study the graph at the same time. We're going to think about domain and range, all right? So let's get started. Okay, well, we understand, right? We understand that we already have this unit circle. From this unit circle, we can find out about sine value of any special terminals, right? Angles with any special terminals and non-special terminals. Yes, we can, okay? All we have to do for those non-special situations, we have calculators. We can find out those values, right? The special terminals, the angles with special terminals give us more convenience because those numbers are much studied and they are representation of all the possible situation. And these are considered the simpler situation and it's more used academically. They're more used academically. So what we try to do is that we only want to put the angle and the ratio, because this is the input and that's the output. So in our situation, right, the input is going to be the angle. The output is a ratio. Okay, so the input is angle and the output is ratio. Okay, so in that input output perspective, okay, so let me write it down. Output perspective, we are really interested in, right? We're really interested in our case, right? The angles, right? And the ratio, okay? And the ratio. And the ratios. And what is the ratio in our consideration for sine? It's a ratio of y over r. Okay, so in the case that when we are working on the unit circle, right? In the previous weeks, we have talked about the rate that, we can use unit circle. So in the case that unit circle and r equals to 1, so it's just y. Right? So if we look back to our lectures in the past, that we have all these discussions. In fact, we have worked out all of these points on our own in our lectures, right? And we decided that, so in that case, r equals to 1, right, for unit circle, but y is a ratio. But what are y now? We recognize that for each of these terminals, the blue numbers are the y's. Okay, the blue numbers are the y's. So let's see, what are they? Okay, let's review. If we have an angle, right? If we have an angle, its terminal, say its terminal is pi over 6. It's pi over 6. Measure from the standard position. So terminates right here. This is pi over 6. Right? This is pi over 6. Pi over 6 is this angle. Pi over 6 on the unit circle, this piece, okay, I'm gonna use a very special color. I'm gonna use this gold color, okay? This gold color is also the arc length. So this piece is pi over 6 as well. So this piece is pi over 6 as well. Okay, so this arc length is pi over 6. And this angle in radian is also pi over 6. And we're gonna use this arc length, okay? We're gonna stretch it straight. We're gonna make it straight. And we put it here because this is the input. This is our input. This is the angle, right? Angle pi over 6 had the same value as the arc length pi over 6. And this arc length pi over 6 is going to be straightened straight. We're going to stretch it straight. And so that's pi over 6. You see that? That's pi over 6. Now, what is the sine value? The sine value is this guy. Okay, this is the sine value. This is sine value, y. Okay, so that's the vertical. And this is consistent with our previous work, right? When we had a function, the horizontal measurement is for input and the vertical measurement is for the output. So this is the making of sine function. This is the making of sine curve, okay? This is the making of sine curve. Once you understand this, every other points are made in the same way. Consistency, right? Consistency. So once again, for pi over 6, okay, this is the arc length. This is the arc length, and that's the arc length. Stretch straight, okay? And this arc length has the same value as the angle pi over 6. And the ratio for sine ratio is half. So output, input, output. Input, output makes the point. Input, output make the point. Okay, then how about 0? right? How about 0? Of course. For 0, angle 0, right? Or any angle that terminates on this terminal, right? Any angle terminates on this interval. That starts with 0, 0, right? And that's the terminal, and the point is 1, 0. The blue number is the sine ratio. Where would that be? And of course, in this case, it's gonna be the dot over here. It's gonna be the dot over here. Okay, so let me put that dot in place. That's for 0. That's for 0. Okay, so we're gonna put the blue dot. So we're trying to be consistent. Okay, I'm trying to be consistent. So you can have that color coordination when we are, when we look at these pictures, right? That's for 0, right? When the input is 0, the output is also 0, right? When the angle is 0, the output is also 0 because Y is 0. R will never be 0, right? R will never be 0. YR will never be 0. So let's look at the definition one more time. YR will never be 0 because the point on the terminal, on the terminal side of the angle cannot be the origin. Okay, so this guarantee that R will never be 0. If R is never 0, in other words, right, we never have a 0 denominator. We never have to worry about it. Every single point, okay, every single point on the unit circle, right, has a Y coordinate, okay? And that value is going to be the sine ratio. It's the output for sine. So think about domain. What do you think will be the domain? Okay, so we're not going to answer that question immediately, but I want you to think about it, right? And now you can see this half, and for pi over 6, which we just did, right? 0 is here. For pi over 6, for that input, the output is half. So I'm going to draw that vertical line right here. So this half, this blue half is the same as this blue half. Okay, so I shall make them the same because they are the same, right? It just have to be proportionally, done. Okay, so this blue, so what I'm trying to do is I'm going to measure this 1 and this is 1. So these two ones are going to be comparable, right? These ones are going to be comparable. That way we can have a decent comparison. So I think now they are above the same, right? Otherwise I can make it just a little bit shorter. And over here, I just want to have a good visual, okay? Because they are the same value. It's just the, the coordinate we set up, right? And I think that's okay. I think that's okay. Okay, we have these coordinates right here. All right, if we like to be a little cleaner, let's see if I can make it just a little bit cleaner. Okay. All right, so that's 1, that's half, right? So we don't have those other accessories. So this is a cleaner. So you can see the points on the sine curve represent the horizontal measurement is the arc length of the angle of the terminal measured from the standard position. Okay, then you see, how about we go around and around? Yes, then those arc lengths will be counted as such, right? Because if you go beyond 2 pi, then the point will be, the arc length will be further in that direction, okay? So right now we're gonna do these 3, we have done 0, we have done pi over 6, we're gonna do pi over 4 and pi over 6, pi over 3. And I would like you guys to be involved as you're watching this. Please grab a piece of paper, I have a paper pencil with you, and we're gonna do this together, okay? So the next point, we're gonna do pi over 4, okay? Pi over 4. Pi over 4, once again, we want to review the definition of function, right? And we review on the stage set, how do we measure pi over 4? Okay, pi over 4 is measured from the standard position and terminates over here, right? And this angle is pi over 4 because we measured counterclockwise. And there is, okay, there is an arc length. Okay, this is the arc length. Okay, forgive me, my drawing is kind of awkward. It should be a nice arc length. This arc length, okay, in gold color. Okay, I should measure in this direction, right? But I cannot draw it very well. So this arc length, imagine it is smoother. Is gonna be the arc length underneath, right? And this is a pi over 4. This angle is pi over 4. This arc length is pi over 4. Okay, that arc length is pi over 4. And now, so this arc length pi over 4 is taken and stretched straight and is a positive because we measured counterclockwise. So what are we gonna do? We're gonna put it in a similar position as pi over 6, just like that. It's just gonna be a little bit longer, okay? So let's look at the next picture. In the next picture, we're handling the pi over 4. Okay, the pi over 4. Hold on, there. Okay, the pi over 4. Okay, pi over 4. Let's do it again. Do you have your paper pencil with you? Okay, so the terminal is here. Okay, and the arc length. Okay, the arc length. Ideally, I would draw the counterclockwise direction, but I cannot control my mouse as well. So I'm gonna go from up to down, okay? So it should be going this way. I think that would be better demonstration. But anyway, this arc length is stretched straight. So that's pi over 4. And what is the ratio? The ratio is the blue number, that's the y by definition. So root 2 over 2. So this blue height, the vertical, you see, input, output, completely consistent with everything we have done so far, handling functions with input and exactly one output. You see that? And this angle is pi over 4. This angle is pi over 4. Okay, this angle is pi over 4 in radian, okay, and this piece on unit circle, the arc length is pi over 4. So we take the arc length, pi over 4, and we lay it down here, and its ratio, sine ratio is a vertical, okay, input, output, right? So one more time. I asked you guys, maybe you like to pause. Okay, pause and then you start working on for pi over 3 on your paper. Okay, you have seen the answer on the screen, but I just want you guys to do it do it on your own for pi over 3. Okay, for pi over 3 and pi over 2. Pi over 3, right? Pi over 3, once again, the arc length between the standard position to the terminal on the arc length over here, right? So this piece of arc length, okay. So this piece of arc length, okay, pi over 3, and the blue number and the sine ratio, root 3 over 2, okay? Consistent, all the points, okay, for pi over 2, okay, so that's pi over 2 arc length, right, which is a quarter of the circle, arc length, which is a quarter of the circle, okay, and then the blue ratio is 1, so this piece is 1, so pi over 2 comma 1, okay, so this is how we read the curve, this is how we read the sine curve. Of course, now, if you look back to that sine curve, And I hope you see it with, I hope we all see it with better understanding of that curve, right? So we can just keep going, okay? We can just keep going, okay? If you need to go back to watch it, feel free to do it. But I think since this is a recorded lecture, you can watch it, you can play forward, backward, you can do that. So I'm just gonna keep going. Okay, I'm just gonna keep going. So these are the, these are the, I put the bars together, and I also want you to do a comparison. Okay, so now we understand all of these bars, right? We understand all of these bars, the blue bars, right? The blue bars. So these are the ratios, okay? Half, square root 2 over 2, root 3 over 2, 1, right? So that's from 0, right? From 0, I should put 0 over there. So that picture didn't have the 0 because 0, 0, that's a special point too. It is just, the input is 0, right? The output is 0 as well. The blue number is also 0. Okay, but let's see, I'm gonna put that dot over there. Okay, right there, okay? So we put, this is a half, this is root 2 over 2, root 3 over 2, 1, and then it started coming down, right? So for 2 pi over 3, we have that. 2 pi over 3, we have this much. So for 2 pi over 3, this is the arc length. Okay, for 2 pi over 3, that's the arc length. You can see we continue to do that arc length for 2 pi over 3, 2 pi over 3, and that's root 3 over 2. That's root 3 over 2, okay? So you may like to mark it yourself, and then coming down. And what is the highest input? What is the highest output? What is the highest output? 1, positive 1, right? So if you look at these blue bars, they're really corresponding to each other. They corresponds to each other, right? So that root 3 over 2, root 2 over 2, and right here. Okay, half, right? So these blue bars, right? These two are together, right? For pi over 6. And the second one, pi over 4, pi over 3, and 1, right? 2 pi over 3, right? And the next one is, 3 pi over 4 and 5 pi over 6, right? So if we mark all of these points like I did earlier, and if we connect the dots, and this one, this dot is when the input is pi, okay? When the input is pi. What happens if the input is pi, right? We measure from the standard position and we go around half circle, right? And this point is -1, 0. That's the point on the unit circle intersecting with the terminal, right? This is the special case. It's a special case. And the blue number is 0. So when x is pi, when input is pi, not x is pi, it's the input angle is pi, the ratio is 0. So that dot is right here. It's right here. So now we get, if we connect the dots, okay, we can see our sine curve. We can see our sine curve. Okay, we could continue this way, okay, but rather I'm going to do it counterclockwise. We just did a counterclockwise. We are going to do clockwise. Okay, so we're going to do it in the other direction. I want you guys to do it with me. Okay, I want you guys to do it with me. Okay, so please take your paper pencil, right? We're gonna work with clockwise we're gonna work with the points clockwise, okay? I already get started on this one, okay? I already get started on this one. This piece is a negative pi over 6, negative pi over 6. So when we measure the angle, right, we start with, hold on, for this is a negative pi over 6, right? This is negative pi over 6. How do we measure the angle? The angle is measured clockwise because it's a negative angle, negative pi over 6. And the terminal is right here, right? This is the terminal. Now, this angle, because the way it's measured, is negative pi over 6. Okay, so this angle is negative pi over 6, and this piece is negative pi over 6 too. So this arc length is negative pi over 6. Okay, so the arc length, okay, let me make it a little thicker. This arc length is negative pi over 6. This negative pi over 6 is stretched straight. And the ratio, the sine ratio is negative half. The sine ratio is negative half, okay? So I would like you guys to continue to do all of these points, okay? For negative pi over 4, forget the 7 pi, don't use these. We're gonna use negative angles, okay? Actually, I get the picture from internet, but some of these things I think doesn't need to be there, okay? There are different ways to measure angle. So this is how we measure the angle. This is negative pi over 6, okay? This is negative pi over 6. Negative pi over 6. The arc length is also negative pi over 6. You see, it's beneath x-axis, and it's also because it's measured clockwise. So this angle in radian is the same as the arc length. We take this arc length, negative pi over 6, and make it straight and just put it right here. And that's the input, that's the output, if I have made myself clear, okay? So now I'm just going to mark this point. I'm gonna mark this point. And you guys, if you understand, you can continue to add your other points. Okay, so negative pi over 6, and this is a negative half. Negative half. You can see some of these are your homeworks, right? Some of these are your homeworks. Okay, some of these are your homework. Okay, when I assigned your homework last week, I do have the intention that I'm going to use it in the following week. Okay, in the following week, in a different capacity, So now you know it, right? Now you know it. So now all those points has a physical appearance, And so let's look at negative pi over 4. Okay, so let's look at negative pi over 4. So please do that. Okay, so I'm going to draw the negative pi over 4. Okay, so I'm going to draw the negative pi over 4. Okay, negative pi over 4. Okay, and there's also that point we're going to draw. Okay, and let's see if we get that right there. Hold on, I think I forgot to choose the dot. That's right, negative pi over 4, right? And keep going. Okay, I want you guys to keep going until negative pi. Okay, so let's go there. Okay, let's go there. Okay, so we're gonna do this together. I want you guys to take the time as I'm holding your hand. Okay, I'm holding your hand. So the next one is negative pi over 3. Okay, so negative pi over 3. You don't have to worry about the software I'm using, but you do see the point, right? You do see the point. Okay, we also have lots of other things to observe, right? So this definition is a wealth of information. It's a huge wealth of information. And we're not done with the definition yet. We're not done with the definition yet. From this definition, we can figure out so many things. Okay, so we keep going. Okay, we keep going. So the next thing we're gonna do is negative pi over 2. Okay, the next one we're gonna do is negative pi over 2. Okay, when it's negative pi over 2, okay, the ratio is -1. The ratio is -1. So we get to this point, okay? And now we have this entire quarter of the circle finished. Okay, there. Okay, so we've done negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Continue. Here, you cannot use the number 11 pi over 6, okay? You cannot use these numbers if you see them, okay? Ignore them. You think about measuring these angles, right? You think about measuring these angles from this perspective, okay? From this is a pi over 6, right? And the ratio is negative half, right? And then is negative pi over 4, and the ratio is negative root 2 over 2, and negative pi over 3, right? And the ratio is negative 3 over 2, and until the ratio, the angle, the arc length is negative pi over 2, and the ratio is -1. Okay, you can see all of these negative numbers, they are underneath the x-axis, if that makes sense to you. And next, we're gonna continue this journey. Okay, keep going. So this is gonna be negative 2 pi over 3. Negative 120 degrees. Okay, if you need to do the conversion, okay, feel free to do the conversion. Pause the video, pause the lecture, and do the conversion yourself, okay? So the next angle we're gonna do is gonna be this one with terminal at a negative 2 pi over 3, which is a negative 120 degree, negative 120 degree. All right? So where would that be? That's gonna be, we'll continue to have these, the gold, right? I need to extend it. All right, so let's do it. Okay, so negative 2 pi over 3, negative 2 pi over 3. Okay, negative 2 pi over 3, and I need to draw the gold color as well. And you do yours. It takes a little bit longer because I have to manipulate with the softwares to give you a better picture. Okay. So that's what I'm trying to do. And this piece, I'm gonna give you that gold arc length. The gold arc length. Okay, so let's see, where's my gold arc length? And there you go. I should show it there. Okay, so to make it clear, let me show you, okay? For this angle, right, I measure clockwise. So the measuring of this angle is clockwise from the standard position. You see, I'm still on the stage set, right? And on the unit circle, so this piece, okay, this angle is negative 2 pi over 3. Okay, the radian. And this arc length, okay, is the same as this gold piece. It's just this one is curly and this is straight. So this piece is a negative 2 pi over 3, and it's on the left side of origin because it is negative. You see how consistent we are, right? Now, what is the output? The output is a blue number, negative root 3 over 2. Negative root 3 over 2. Got it? So next, I'm going to put that point on the dot. Okay? So I'm going to add that point, which is negative 2 pi over 3, comma, negative root 3 over 2. And that should be a blue dot because it's a sine ratio. It's a sine ratio. Okay, so we try to be consistent with the color. So keep going, okay? So you have 1, 2, 3, 3 more to go. 3 more to go. So let's do it, okay? Let's do it. And you are doing that. You can turn off the recording, but I'm just going to keep going. And then you come back to compare. Okay, so the next one is going to be negative 3 pi over 4. Negative 3 pi over 4, not the 5 pi over 4, because that's the measure of counterclockwise. We're measuring clockwise. Okay, so that's going to be 3 pi over a negative 3 pi over 4. Right, so we're going to have negative 3 pi over 4. Wait, okay, you don't have to worry about how I use the software, okay? And I'm going to put it. Okay, that's a dot. And this piece is going to be gold. This piece is going to be gold. Okay, that's going to be gold because it's a measure of the oh no, I think I didn't draw that thing. Okay, but you can just take your time to do this. Okay. Oh, not dots, it's a line. That's why. Okay, there. Okay, so negative. So let me do this one more time in case that you are lost, right? So this piece, I'm gonna measure the clockwise measurement from the standard position, right? We're on the stage set. Measure negative 3 pi over 4. This is a negative 3 pi over 4, okay? Yes, we are repeating the same theme. You see the consistency of mathematics, okay? So negative 3 pi over 4. And the arc length, okay? The arc length measured from the standard position is also negative 3 pi over 4. Okay, I'm doing this slowly. It's still not perfect, but you got it, right? So this arc length is negative 3 pi over 4, and we take this arc length and we make it straight, okay? Straighten it up, right? And that ratio is negative root 2 over 2. So this height, okay, this height. So this piece, this gold piece is 3 pi over, negative 3 pi over 4. And this height, this blue, is negative root 2 over 2. If that you still get it, right? I'm sure I have been repeating over and over, okay? I hope it helped. Some of these questions will show up on your quiz. You should not be surprised because I cover these things in so much detail and I want you to watch the video, okay? Now, without further ado, we have 2 more points. If you wish to go back to watch, feel free to do that, okay? So what will be the next one? The next one will be measured still clockwise. So we're gonna terminate at negative 5 pi over 6, okay? Negative pi over 6. Now I want you to do the whole thing, negative 5 pi over 6, okay? To experience that, the whole process, okay? ARD, you experience the whole process of ARD. That's what I wish you to experience, okay? And that experience, I assure you, is gonna be valuable for each one of you, okay? Sometimes you may find this tedious, okay? You don't have to do it 10 times. You only have to do it maybe 1, 2, 3 times maximum, okay? So negative 5 pi over 6, negative 5 pi over 6. So that's the point, right? That's the point. And next, right? I'm just doing this, okay? Over here. And we're gonna make that gold, right? That's the gold, one more. And now it's the point, it's the blue point. There, okay? So this point, okay, let's mark this point, right? The total gold length, which is an arc length from the standard position clockwise terminates here, which because the terminal is with negative 5 pi over 6. So this piece, okay, let me write it down. Negative 5 pi over 6, I meant to use the gold color. Okay, so we're gonna do color code as much consistent with ourselves as possible because I want you guys to really understand this, okay? If you understand sine, it's easy to understand cosine. Tangent, cotangent, they're all the same thing, okay? Secant, cosecant, of course, different ratios, all the same idea, okay? So this gold piece is the arc length from here all the way to here. Okay, so let me draw that piece. So you see the consistency, Oops, that's too thick. Too thick, okay. Take your time to do this. I believe that for most of you, you probably only have to do this once. Make sure you do that once all by yourself. So this arc length, okay? And of course the terminal is here, right? This arc length, okay, I'm gonna remove that. I'm gonna change the color of that terminal so it doesn't confuse you, okay? It doesn't confuse you. So that gold arc length stretched straight is negative 5 pi over 6, okay? So that point, what is that point? It's the input for sine function and output for sine function, okay? So let's mark that point. In fact, I want you guys to mark all of these points. Okay, we're gonna come back to mark all of these points, okay? And then I will turn around and I quiz you, okay? Now, this point, you're gonna see this multiple times. So you have no excuse, okay? The input is the gold color, okay? Negative 5 pi over 6, 5 pi over 6. and the output is the blue, which is -1/2. Oh, sorry. We gotta use a blue color, right? We gotta use a blue color. The blue color, -1/2. Okay. And for each one of these points, okay, we're gonna come back to mark them. Okay, we're gonna come back to mark them. I said, just recap what we have done. Okay, what we have done. Next, last one. Well, last one for this section. Okay, we can keep going. We can keep going forever, right? And I hope you get the hang of it. And then we're gonna mark the point. It's the -π. -π. Okay, so let's do the -π. Okay, so now I'm gonna clean up, right? Clean up. Okay, -π. How do we measure -π? Definition from the standard position, right? Clockwise, -π. The negative sign tells us it's measurement clockwise. Okay, so that's -π. And what is the arc length? The arc length is the half circle. It's a half circle. The arc length is a half circle. Okay, I'm not gonna do a perfect job, but I hope you get it. This is the half circle. Okay, this half circle, okay, is going to be the input for this point. For this point we're about to plot. Okay, the input is -π. Okay, and the output is 0 because that blue number is 0, right? We've gone through that in previous sections. And if you have questions, please don't hesitate to ask me, okay? But now I assume you already watched the previous videos, right? So this gold arc length is gonna be longer, right? So let's mark that point, okay? Let's mark that point. Okay, so I'm gonna do just that. -π. Where's my pi? There. I already did pi, right? Now it's -π. -π, -π. Wait. -π, okay? That should be, wait. What do I get for that one? -π 0. I think that point should be 0, 0. Okay, so that should be the gold color. Okay, that should be the gold color. So that piece there. Okay, you see how long? It's about -3.14, right? So I set it up in that way. And of course, there's a 0. There's a point. There's a point right there. Pi, -π, comma 0, and it's going to be that blue dot, right? That blue dot right there. Okay. So now we're going to mark all of these points in front of us. Okay, you will see a lot of these points are a lot of these calculations you have done in your homework. Right? Now, let's get started. The first point, we have marked them, right? The first point, this point. This point is what? Can you guys mark that? This point is, oops. Okay, the first point, because this time I'm going to mark it with a slightly different order. Okay, I'm going to mark it with slightly different order. Okay, So this point, the first point here, okay, is the gold color, okay, pi over 6. One half, the blue number, 1/2. Now I'm gonna mark the next one, this point, okay? So this point, I will also have, we'll have a negative half. And the angle, what is the angle? The angle or the arc length is a negative pi over 6. Okay, I'm gonna do a little cleaning up of the axes, okay? Just 1 second. You guys keep going, okay? Mark the points. And this is not a test or a quiz, right? You can feel free to go back to look at your notes and to watch the previous pieces, right? And other things we like you to think about, because looking ahead, right? We're thinking about domain range, right? In this session, we're talking about domain and range. And of course, we're gonna work out the graph. And at the same time, we're gonna think about domain range. In the future lessons, we're gonna be talking about increasing, decreasing, okay? One-to-one functions, right? One-to-one functions, increasing, decreasing. And also even function, odd function. Okay, we're gonna think about those concepts, don't we? We have introduced those concepts before, right? Now we have a function. We're gonna check on all these concepts if any one of them is true, right? And after all, these are the basic concepts we're gonna deal with the whole semester for different functions, okay? So you're gonna see that repetitive theme for different rules, okay? Function, one-to-one, you know, increasing, decreasing, even, odd, okay? And of course, for function, we also talk about domain and range, right? So right now, that's what we're doing, okay? So this is the 2 points, right? So are you ready to mark the next pair? Now you know my intention, right? We're gonna mark these 2 pairs. The next, okay, let's go. So I'm gonna clean this up. Okay, we're gonna mark the next point. The next point are this one and that one. And this guy is going to be, okay, this point, okay? This point is gonna be pi over 4, which is a gold color. That's the arc length. The input is arc length or the radian degrees, right? And the output is the blue, which is gonna be √2 over 2. And that's this point, okay? How about this one? This point, we have the gold, okay? Negative pi over 4, right? Input are opposite. What happened to the output? Output are opposite too. Ah, that's interesting. I wonder if that's the case for any input, right? All right. So that's for this pair, Okay, let's do the next pair, this one and that one. Okay, are you ready to go? All right, maybe I'm behind you. I have the impression I might be behind you, okay, which is good, okay. The next one is that we're gonna look at this point, and that's gonna be pi over 3. And the output is in blue, √3 over 2. Okay, on this side, right? That's a negative pi over 3. and the output is negative root 3 over 2. Okay. All right. How about the lowest dot? Is it the lowest dot and the highest dot? Okay, the lowest dot and the highest dot. Okay, I want you guys to do these points because you will understand why I do it here. And we will in the future. Okay, we have other topics we're gonna cover and you're gonna see the same, you're gonna see the importance that I want to make connection from with what we've done before and what we are about to do in the future. Okay. And next, the lowest point and the highest point. What is the lowest point? What is the highest point? Obviously, this is the lowest point, right? It's very visual. The lowest point, the highest point. So let's mark these 2 points, okay? Take our time. So the highest point, okay? The gold color is pi over 2. And this blue bar is 1. And the lowest point, okay, the lowest point, oops, whoops, sorry, this needing to be the blue color. We have to be consistent with ourselves, okay? That's what I like to do for you, okay? Because this might fit some of you guys' learning style, okay? Next one, the lowest point. The lowest point. Now, are you thinking about domain and range? Think about domain and range. Remember, we're doing the graph at the same time. We are going to discover domain and range, right? That's right. We do things with the intentions and we also observe the points in different ways. How about even, odd, and so on and so forth, right? Okay, let's look at the lowest point. The lowest point. Okay, we've done it, right? So we just have to mark the point. And marking that point is very important as well, okay? And the input is a negative pi over 2. It should be gold color. Okay, so I'm going to be consistent with myself. Okay, and I promise you. So that's a negative pi over 2. Opposite input. Opposite output. What does that make you think? Huh? What does that make you think? Right? Lowest point, highest point. The output, right? You can see the input can keep going in the direction, in these directions, right? To maybe to infinity. And the input can go to infinity, right? We keep going, right? We can go around and round and round. There's no point, no terminal so far we have to avoid, right? So what does that say about domain? But what does it say about range? Because we have gone a full cycle. We have gone a full circle, right? Half circle is this way, half circle that way. We have covered every point on the circle. Well, not exactly every point, but all the typical points on the unit circle with special terminals, right? And there are a lot of points in between, of course, and the lowest point and the highest point. And before I go on, let's take another perspective, right? So this piece is half. That's, oops, no, that's not what I want. Okay, look at the blue. Look at the blue, okay? Each blue, right? That, we're gonna see it here. This blue, that's half. That's root 2 over 2. And that's root 3 over 2. So these 3 is 1, 2, 3. You see 1, 2, 3 there. Okay, they're the same. The highest. Okay, and the next one, boom, boom, and boom. Okay, the next three, 1, 2, 3, right? And now how about the negative ones? The negative ones, we see them here, right? We see them here, there. All these blues, right? And you can see 1, 2, 3, 1, 2, 3. The lowest one, right? And 1, 2, 3. And here we're going to see the 1, 2, 3 correspondence. Okay. So now, what do you think will be the range, and what do you think will be the domain? Right? So could you continue to mark these other points? Can we continue to mark the other points? Okay. So let's stay quiet for a minute. I'm going to mark, and you mark yours on the paper. Okay. You mark yours on your paper. Okay. So I'm going to mark. Okay, so let me do this. Okay. This point, I'm going to mark it. Maybe you want to just shut down or pause at this moment. Okay, pause at this moment. Okay, so that's going to be 2 pi over 3. Okay, and the blue number is √3 over 2. And that one, this point, is 3 pi over 4. It's a gold color. And that √2, wait, change the color. Okay, change the color. So that's going to be √2 over 2. On this other side, this guy, right, is negative 2 pi over 3. Opposite input, opposite output. And that piece, oops, my bad, color. I really like that color tone. Let's do it right, okay? Help me, God. Next, negative 2 pi over 3, right? And this one, that's gonna be, this is negative, right? This is negative 3 pi over 4, negative 3 pi over 4. And the output is negative √2 over 2. This last one, this last pair, okay, so let's see if I can fit them in, because I don't want them to be too crowded, because I know I'm gonna write kind of not as pretty as I could, because I have to use a mouse to write it. So this is gonna be 5 pi over 6. 5 pi over 6. And the output is 1/2. So ugly. Please forgive me. That's half right there. Okay. This place, and the next one, which is right here, I think I can fit it in. Right. The gold color, okay, negative 5 pi over 6. 5 pi over 6. And the output Okay, it's negative half. Negative half. There. Last but not least, this last pair. Okay, this point, which is going to be it's a pi, comma, the blue 0, okay, which is right here, okay? And this point is the orange color, is a negative pi, comma, 0, okay? So that means sine negative pi is 0, sine pi is 0, right? So make sure you write it down for yourself. We have marked all of these points. You should not be surprised. You should not be surprised, and I'll be asking you to mark these points on one of those quizzes. Maybe this week and maybe in the future weeks. Okay, so now if we keep going, we have gone a full circle, right? Now, can you imagine if we continue doing this, what will happen, right? If I have gone in the counterclockwise, I will have 7 pi over 6 here. If I keep working on the 7 pi over 6, so this arc length, so it's going to be going in that direction, right? It's going to be going in that direction, okay, the gold color. Okay, so it's a negative half, so it's going to be below it. It's going to be below it, right? So let us take a look at that, okay? With all of these said and done, can you imagine the other points? Okay, so what I'm going to do is I'm going to copy and paste this picture, okay? And I wish you to have your unit circle in front of you, right? What I'm going to do is that I'm going to do the following. Okay, just going to show you a couple more points. Okay, I'm going to show you a couple more points. Okay, because we gone half circle counterclockwise. We did half circle clockwise, right? So we have these pieces. What if I'm going down further, right? And I need to reset I'm going to set in one direction, right? I'm going to set in one direction. Right? Just like that. Okay. I make it just a bit longer. Okay, we're gonna get a few points. We're gonna do a few points. Okay, our intention is to get to the full circle of 2 pi. Full circle of 2 pi. Can you complete that, right? So this time we have done this way, right? We've reached a pi 0. So the next one will be what? Would be this piece, this terminal. We just use it to do the special angles, okay? All right, so take your time. Let's do it together while we understand it, right? So let's continue to do it. Okay, with our unit circle next to us, right? This unit circle next to us. So the next one, so let me show you what is my intention, okay? I know by this time you understand everything, but we need to practice, okay? So this time, from the standard position, we measure counterclockwise, okay, over the half circle, okay? And once again, we get this arc length. This arc length is 7 pi over 6, 7 pi over 6. So this gold is going to be longer. It's going to be longer. And what is the blue number? Negative half. Okay, so that's what we want to demonstrate. Okay, so let's keep going. Let's keep going. Okay, now, so you guys keep going, okay, on the other ones. Okay, so I'm going to continue. Oh, wow, I have to, hold on. just a little bit. Okay, let me do that. Okay, so this should do. Okay, so as you're looking at that picture and I'm looking at the same picture, I'm thinking about the definition of functions. I'm thinking about the stage set of trig functions, okay? That's what I'm thinking of, okay? I'm thinking about all of those things, okay? I'm thinking about all of those things, okay? So now it's 7 pi over 6, 7 pi over 6, okay? Seven pi over 6. So the gold, right? So you're gonna see the gold color. And then you're gonna see that point in blue. There. Okay, you see now this whole piece is 7 pi over 6. This whole piece, okay? That whole piece is 7 pi over 6. Okay, this whole piece. Wait a second. There. Okay. 7 pi over 6. Okay, so from here, 7 pi over 6. And you can continue, keep going, okay? I'm going to do until 2 pi. Okay, so we have some more points to work with. Okay, so important that we do the full circle. Okay, we do the full circle counterclockwise. I will leave the clockwise. Maybe we'll have time to do it, right? So let's do the counterclockwise, right? So this point. Okay, let's mark this point. This point is 7 pi over 6. Okay, and the blue number is -½ Okay, so even if you think you got everything, please continue to finish. Okay, we're gonna do that full circle. I assure you, very few textbooks have done this. Okay, very few textbooks have done this. So we're committed to do this because we want to have full understanding. Okay, so the next is 5 pi over 4. Okay, 5 pi over 4. 5 pi over 4, right? The ratio is -√2 over 2, right? And we're gonna draw that gold color. The gold color there. And the point in blue. And we are consistent the whole time. We're consistent the whole time. Okay, the software certainly made some adjustment for me, right? That's the point. And this new point, okay, so if I'm going to clean it and mark it again, you can see this point. I have never seen any textbook done it, okay? Then you say, well, is it necessary? I find it necessary, okay? So please do it. And this is going to be 5 pi over 4. That's a gold color. Once you understand this whole thing has been done, you are going to be so much at ease. So much at ease because you understand it now. So that's a √2 over 2. Okay. So just a few more points, right? We're almost there because we're going to do the 3 pi over 2. Okay, 3 pi over 2. All right, let's go there. Okay, so the next point. Okay, keep going. Keep going. You guys keep going. 3 pi over 2. Okay, we can do this, right? No, this is going to be, I'm sorry, 4 pi over 3. What am I saying? 4 pi over 3. Okay. Counterclockwise measurement. Okay, counterclockwise measurement. So this is going to be that. And add this point. And then the gold color. The gold color. One more. It's going to be the blue dot. Consistent. Next point. The next point. Right? No, not this point. Sorry, I need to clean this up. Okay. So on this point, right? It is the measurement. I can't stop reminding you because it's so important that you keep that in mind. We're on the stage set, okay? Measure counterclockwise, terminates here, okay? That's a 5 pi over 4. That's a 5 pi over 4. You can figure out the degrees, okay, if you have a question with that. And the arc length is the whole thing measured counterclockwise. This arc length, okay? And that arc length, right, is gonna be, it's over here. Oh, wait. Am I doing 4 pi over 3? Oh, never mind. I think I made a mistake. We already did it, right? We already did the other one. 4 pi over 3 is here. It's not 5 pi over 4, sorry. So this one, 4 pi over 3. Okay, 4 pi over 3. We did the 5 pi over 4, right? We did the 5 pi over 4. So we're working on this dot. I think we get to close this, right? Because I'm a little tired. It's about time to take a break. But anyway, so that arc length, okay? So that arc length is going to be measured from over here. Is a counterclock measurement. That's why it's a positive. That's why this arc length is on this side, right? So this entire thing is that arc length, which is a 4 pi over 3. This is a 4 pi over 3, okay? 4 pi over 3. And the ratio, the sine ratio is negative √3 over 2 right here. So this height, okay, is negative, wait, I mean the blue color, come on blue. Okay, I need the blue. So this is a negative √3 over 2. Okay. Oh, forgive my writing. Okay, so this is better. Okay. I really want to get to the 3 pi over 2. Okay, 3 pi over 2. Okay, this is a very important point. When we talk about domain and range for tangent and so on, it's still a very important point. Okay, so I want you to have some sense of it, Anyway, so I'm gonna clean this up. Okay, so next we're gonna do this angle. Okay, we're gonna do this angle. This angle is measured from the standard position counterclockwise and terminates at 3 pi over 2. Okay, And the arc length is 3/4 of the circle measured from the standard position. It's a positive angle, so this would be gold. Okay, there will be a gold measure. Okay, so I'm going to measure. No, I'm going to measure that later because otherwise, when I do this, the software is going to shift place, right? So I want each one of you guys to get involved, get your hands dirty. Okay, so 3 pi. Wait. This is pi over 2, right? Where's my pi over 2? Here we go. Never mind. I'm just going to measure 3 pi over 2. Okay, the gold color. Okay, check out. This is 3 pi over 2. Okay, this new gold color is 3 pi over 2. Okay, and then what would be the ratio, right? The ratio is -1, the blue number. Okay, the blue number. You guys have your eyes on the unit circle? Okay, you have your eyes on the unit circle, right? The blue number is -1. Look, it's -1. So I just have to mark that point. There. Okay, so this point over here, 3 pi over 2. Wait, not 3 pi over 2, -1. And this is going to be the blue bar. Okay, the blue bar. And the point is going to be there, the dot. No, the point there. -1, the height is -1, okay? Now we could, if you, let's see, there. I'm gonna move my picture elsewhere. I'm not even sure you can see it. Okay, so how many points we have to go? 1, 2, 3, 4. Okay, we're gonna do all the way up to 2 pi. Okay, so how about you guys just take your time to do it, and I'm gonna do my own work. Okay, and I will show my work on the screen. As you're doing it, you can come back to compare, or you can pause. Okay, you can pause. Feel free to pause. The next angle I'm going to do is counterclock measurement 5 pi over 3. Okay, so 5 pi over 3. 5 pi over 3. 5 pi over 3. Okay. So I need a little concentration here, but I will speak as I go. Okay, the gold. And it's thick. And the point is going to be 5 pi over 3. Wait, that dot didn't show up. Most likely is that it didn't pick point. Yes, the point. Right there. Okay, you see, this is the steps that you go through. Once you've done it 1 or twice, 3 times, You never forget, and you fully understand the picture. Once you understand sine, then you understand cosine, tangent, cotangent, cosecant, secant. They're all made up the same way, okay? So I'm gonna keep going, okay? So this is gonna be 7 pi over 4, this terminal, okay? So arc length, 7 pi over 4. So just be patient with ourselves, okay? We can do this. We can do it, can't we? We can do it. 7 pi over 4. 7 pi over 4. The ratio is negative, right? And we go the next. We're gonna draw the gold arc length, right? The gold arc length. Where are you? And we're gonna add the point, which is a dot. Whoops, I have the wrong color of the dot. Okay, that's not okay. I have to make it right. Okay, I have to make it right. It's gonna be the blue color, right? Blue color corresponds to the blue number. Okay, we have these completely color coordinated. Two more. Okay, this is 11 pi over 6. You can see in this whole process, right? As you pause, you watch, you pause, you watch, you're also converting the radian to degrees as needed and see it better for yourself. If you do this whole 9 yards, I tell you, the service to you is going to be immense. Okay, so 11 pi over 6. 11 pi over 6. Okay, 11 pi over 6. 11 pi over 6. Okay, counterclockwise. The ratio is a -½ and the gold is the arc length. You know what the arc length should be, right? The arc length, which is in gold color, and the point, which mark the input and output, the blue dot, the blue dot. Yes, okay. Last but not least, that 2 pi, finally, we get to 2 pi. Okay, 2 pi is much easier to handle. Okay, so this will be the gold color. Okay, that gold color, 2 pi. Okay, and the point, the blue point is that 0, 0, 0, right? We're back a full circle, 2 pi. There, wait, where's my dot? I think I forgot to do that thing again. Change it to dot, and I forgot. 2 pi comma 0, right? Sine, oh, 2 pi comma 0. I should choose the dot. There you go, that dot. So this is the full circle. This is the full circle. Now, to conclude, right? So let's finally connect the dots. Finally connect the dots. Actually, I'm gonna use the blue color. Okay, to see that works. It should work. The blue connecting all the dots, this is the sine curve. I know you know this curve. I hope that this time you know better about this curve and where it came from. And last but not least, what is a domain? Domain is the horizontal span, right? The angles obviously can be any real number because the arc length can be any number you choose, right? You measure from the standard position, counterclockwise, clockwise. So domain can be any real number. Any arc length on the unit circle can be honored. We can find a place for it. How about the range, right? How about the range? The blue, how far it can go vertically. We did the lowest point and we did the highest point. The highest point is what? +1. The lowest point is -1. So the range sign is from -1 to +1. So let me give you all the different ways of expressing it. Okay, so now we have the curve. Okay, so what I'm going to do is I'm going to bring this unit circle with us. Okay, I'm also going to bring the curve with us. And there we go, right? Maybe I can condense it a little bit, right? To show the work we done, the full circle, right? The full circle we have done. Okay, so I'm going to give you some of the forms we express domain and range, and some of the form that's essential for calculus classes. Okay, domain, horizontal span. On the unit circle means it can go from standard position any way you measure it, as many times I've circled as possible. So this curve will keep going in both directions as needed, okay? So the horizontal span, which is for the gold, right? Can go in both directions as far as possible, as long as possible. So domain is all real numbers from -infinity to +infinity. The range, as you see from the unit circle, right? As we drew all of those vertical, the blue numbers, right? It's 0, it's half, oh, sorry, wrong color, right? There, right? This is you know, just a number between -1 and +1. The highest one is -1. I'm sorry, the highest one is +1. The lowest one is -1. Okay. Could it go lower than -1? No way. Could it go higher than +1? No way. Okay. And there are all these heights in between -1 and +1. Every one of them can possibly be the output for sine. Therefore, the range is -1 to +1. Okay. Many of you probably know that, but this form is not, not the only form. And this form in many cases actually is not that useful. It's not that useful, okay? Algebraically, mathematically, these other forms will be more useful. And as a result, they're more preferred. One is saying x is less than equals to, you know, greater than or equals to -1 and less than or equals to +1. So this is how we read it, okay? For any real, for any x. Okay, how do we read it? Okay, sine x is between -1 and the +1, inclusive, meaning that include -1 and +1, right? Because we can, at pi over 2, sine pi over 2 is 1. Sine 3 pi over 2 is -1, inclusive. Okay, for any real number x. For any real number x. Okay, so any real number x. Any real number x. Okay, so this is a preferred form, and you will find yourself using it in calculus class. Okay, and another form, which is also very useful. Okay, it's in absolute value form. There. Okay, sine x is less than or equals to 1. The absolute value of sine x for any real number x. So these are the 3 forms. These are the 3 forms. Okay, and this form is okay. Okay, if you give me this answer when tested, you probably will not get much point. But if you can show me this one, you're gonna get more points. You're gonna get more points for these 2 forms. And these 2 forms are very, very useful. Very, very useful. Okay, so get used to it. Okay, it basically says the vertical, right? The vertical sine value is bouncing between -1 and +1. Everything, and it could be anything in between, and including -1 and +1. Okay. Well, this lesson is pretty long, but I anticipate you guys need to come back to watch it over and over, I think. Okay. But my goal here is to give you a thorough understanding of this. Okay. What we have done today in this recording, I have never seen any textbook written in this capacity. Okay, very, very useful stuff. It really deepens understanding. So I hope you guys, watch it to this point, right? Till the end of it. Okay, so without further ado, I'm going to take a break. Thank you for watching. Until next time.